Sneha. Okay. Shall we start? Okay. Sneha, Divya. Somnath, Shaurya, Kunal. Priya. Okay. I think why the attendance is less, I don't know, but still okay. It's a revision lecture, it's a discussion lecture. So I will just revise. Okay. Now up to yesterday, day before yesterday, we have covered up to lecture 10. Now in lecture 11, what we have seen? We have seen transmission line protection. In transmission line protection, we have seen fault distance measurement, how Z is calculated, what is the step distance characteristics. Okay, what is first zone? First zone is up to 80%, while second zone is for 40 to 50% of shortest transmission line. While third zone is backup zone. Third zone is backup zone. Okay, this we have seen, and we are using what is the reach of the relay. We are using reactance relay, impedance relay, and Moore relay. Okay, now in this lecture we have seen what is the reach of the relay. What is the reach of the relay? This is about our 11th lecture. Now in 12th lecture we have seen what are the different types of distance relay. Okay, what is the different types of distance relay? We have impedance, reactance, Moore, ohm or angle impedance relay, offset Moore relay, quadrilateral, and other special characteristics. Out of that, impedance, reactance, Moore, and ohm impedance relay is important. Okay, first three is important. Offset we are changing only the settings. Okay, quadrilateral when we require a directional protection. When we require a directional protection, in that also this quadrilateral relay is important. Okay. Okay. Now in this we have seen distance relay. Okay, construction, RX diagram, distance relay operation. Main thing we have seen in this lecture is trip. What is the trip law? What is the universal trip law for distance relay, for impedance relay, for reactance relay, for Moore relay? Okay, we have seen and we have derived it. For impedance relay, how it operates, characteristics of impedance relay, it is a circle inscribing origin. Okay, characteristics of directional impedance relay, then admittance relay, it is circle passing through origin. We have derived the torque relation of admittance relay. Then angle impedance relay, it is passing through, it is having certain angle with Rx characteristics, Rx line. Okay, then trip law for simple reactance relay using universal torque equation. Reactance relay, it is the characteristics parallel to the R axis, or it is parallel to the horizontal line. Okay, this we have seen. Now directional properties of that angle impedance relay is applicable to reactance relay. Okay, because this is our first quadrant, this is second quadrant, third quadrant, fourth quadrant. Okay, when we want directional feature, then we have to implement a directional characteristics, which is by Ohm relay. Okay, these are the different types of distance relay we have seen. Okay, impedance, reactance, Moore, offset Moore. This is angle impedance. This is quadrilateral relay. Okay, this we have seen in types of distance relay. Okay, and a three-step distance protection using Moore. Okay, homework, here you have to draw different characteristics of relay. Okay, using impedance, reactance, and Moore. Okay, this we have seen in our 12th lecture. 13th lecture. In 13th lecture, we have seen what is the effect of fault resistance, the effect of power swing on the performance of distance relay. Okay, now in this we have concluded that for short transmission line we are using reactance relay. For long transmission line we are using Moore relay. For medium transmission line we are using impedance relay because effect of fault resistance is less in reactance relay, while in short transmission line we have arcing fault. That's why fault impedance is more, so fault resistance comes in picture, and that's why this reactance relay is more suitable for short transmission line. For power swings means what? The two generators are swinging with each other, that causes a high transient current, that causes transient from one generator to other generator, so that surges may maloperate the relay. So for this the relay is more suitable for transients, okay, for the transient or for power swings, because the characteristics is like this, while more relay covers less portion of the RX diagram, so it is more suitable. This we have seen in our, I think, 13th lecture, 13th lecture. Now in 14th lecture we have seen carrier added distance protection. Okay, as we have seen, we have three-step distance characteristics. First zone is 80%, second zone is 20 to 40%, and third zone is backup protection. Okay, that means it is protecting only 80% part of the transmission line, while 20% remains unprotected. So for that we have carrier added distance protection. Okay, we have seen various equipment for carrier added distance protection. We are using pilot distance. First thing is wire pilot, then carrier pilot, then microwave pilot. Okay, so in pilot protection we are using physical wire is connected from one city to other city. Okay, while in case of power line carrier communication we are connecting equipments, transmitter connected at other end, while a receiver connected at other end. Okay, this is about carrier current protection scheme. Okay, this is our 14th lecture. In 15th lecture, next further addition of that carrier added distance protection, carrier current channel, microwave channel. Okay, I mean carrier current channel frequency ranges from 30 kilowatts to 600 kilowatts. Okay, while the carrier signal is sent to our power lines. Okay, in microwave channel it is 450 megahertz to 10,000 megahertz, and it is transmitted through air. The communication channel is space. Okay, this we have seen. We have seen equipment, carrier equipment. Okay, transmitter at other end, receiver at other end, while transmitter at other end also. That means we have transmitter, receiver end at both ends. Okay, this is our carrier added scheme. Now in carrier added, we have phase comparison and directional comparison. In phase comparison, we compare the phases. Okay, for incoming current and outgoing current. Okay, this we have seen. Okay, function, and then directional comparison, we compare the direction of the current. Okay, this already we have seen in this carrier blocking scheme and carrier tripping scheme. Advantages of both scheme we have also seen. Okay, now this is about our carrier added distance protection. Now next is, now up till now we have covered transmission line protection. Now second protection is generator protection. What are the different faults in the generator? In our which lecture? In 16th lecture we have seen generator protection. In generator protection we have seen different faults in the generator. Then what are the different faults? Stator faults, rotor faults, abnormal running condition. Okay, now how protection is applied, or what are the different protection applied to the generator, that we have seen. Okay, stator protection. Then in that main protection is differential protection. Okay, main protection is differential protection. Okay, for abnormal running condition, we have again different types of protection given to the generator. Okay, that we'll see. This is again differential protection. This is about differential protection. Okay, now in rotor protection we have rotor earth fault relay. For loss of excitation we have we have this loss of excitation characteristic. We have offset mode characteristics applied to the applied for loss of excitation of the generator. Then unbalanced loading. For unbalanced loading, we have negative phase sequence relay. Okay, for overload protection, we have overcurrent relay. For overload protection, we have temperature sensors, temperature detecting coils. For prime mode protection, we have reverse power relay. Okay. For overspeed protection, we are using interlock relay. Okay. For overvoltage protection, we are using overvoltage relay. So these many protections are given to the generators. Now here we have solved one example. Okay. Now 17th lecture we have covered transformer protection. Okay. In transformer protection, what are the different faults in the transformer? Faults in the auxiliary equipment, fault in the transformer winding and connection, and overload and external short circuits. Okay. Now, what are the faults in auxiliary equipment? Auxiliary equipment are transformer oil, gas cushion, oil pumps, core and winding insulation. Okay. So, for that, this wait for a minute. 17th lecture, na? This we have. Now in this, for faults in auxiliary equipment, we have seen gas operated relay, that is Buckles relay, pressure relays. For winding faults, we have for winding faults we have differential protection. For overload and external short circuit, we have temperature detector coils. Okay, so protection for internal faults in the winding in the transformer, overcurrent protection, restricted earth fault protection, differential protection. These many protections are given to the transformer. Now we have seen operating principle. Now here important in the transformer is that how CTs are connected, because transformer is either star-star connected, star-delta connected, delta-star connected, delta-delta connected. If transformer is star connected, then if CT's transformer primary winding is star connected, then CT will be in delta connection. If transformer secondary winding is in delta, then CT will be in star. So that to minimize to equalize the CT, to equalize our spill current, because we don't want any spill current in the difference of this differential operating coil of the relay. Okay. In star delta transformer, the load currents in the two windings are not in direct phase opposition but are displaced by 30 degree, and to allow for this, the CT secondaries are connected in delta on star side and in star on delta side. Okay. So that's why the connection is like that. Okay. Now, about differential protection, they have certain problems. Unmatched characteristics of CT, ratio change as a result of tap changing, magnetizing inrush current. Okay. This problem can be solved by percentage bias differential protection. Okay. Magnetizing inrush current, we have harmonic, even harmonic cancellation, and then harmonic restraint relay. Okay. This is about your transformer protection. Okay. Now 18 lecture is depend upon our bus bar protection. Okay. Here we have again CTs connected, and it is differential relays connected to all CTs. Okay. So for bus bar protection, we are using differential connection or linear couplers we are using. Okay. This is about your bus bar protection. Okay. Now in 19 lecture, we have protection of induction motor. It is same as our generator. Okay. It is same. Some relays are different or ratings are different, you can tell. Otherwise, it is similar to our generator protection. And last lecture of protection is frame leakage protection. And in this, we have covered last part of protection of unprotected winding against phase to earth fault. Okay, this is our frame leakage protection, because we need to give, we have to protect our substation also. Okay, from earth faults. It is possible to design a station so that fault which develop are mostly earth fault. Okay, so for that we have frame leakage protection. Okay. Now in this lecture we have covered percentage of winding to be protected against phase to earth fault. It is 80% winding. Okay, we have solved one problem based on this. Okay, this is up till now our protection. And now you have to tell me whether you have any doubt in protection. Reply in chat box. Reply in chat box. Whether you have any doubt in protection. Himanshu, Ashish, Sanket, Jayesh. Okay. Divya, Kunal, Somnath. Okay. I assume that you have understood everything. Okay. If you have any doubt, you can ask me. Okay. Now, shall we continue this circuit breaker uh, or tomorrow we can take what you can tell? Shall we continue this for circuit breaker? Tushar replied, okay. Okay, because circuit breakers are, this section is very small. So I will continue. Tushar replied, okay. So I will continue. Okay. Ashish, Sanket, okay. Okay, no problem. Himanshu, okay. I will continue. Okay. Okay, I will continue. I will cover in 5 minutes. Okay. Now in lecture 21, we have seen theory of arc interruption. LDI select. Okay, I will cover theory of arc interruption. In that, we have seen lecture 21 fundamentals of circuit breaking, how the circuit breaker operates, what is the arcing phenomena. Okay, what is the characteristics of arc, we have seen in lecture 21. In that, we have seen these three basic definition: what is the striking voltage, what is arc voltage, what is TRV. Okay. Now in 22th lecture, we have again continued with theory of arc interruption. We have solved one problem based on that. Okay. Also, we have seen in this lecture factors affecting rate of rise of striking voltage, recovery voltage, and TRV. Okay. These are the factors affecting rate of rise of striking voltage: power factor of the circuit conditions, asymmetry of short circuit current, short line fault, effect of armature reaction. Okay. This we have covered. We have solved one problem based on this. Okay. Now in lecture 23, we have seen important arc interruption theories. Two theories we have seen: high resistance method and low resistance method. In low resistance interruption, we have Slepin's theory and Cauchy's theory. Okay. This we have seen in arc interruption theories. Okay. Now in 24th lecture, we have seen interruption of small inductive current, that is current chopping. Okay. We have seen interruption of small inductive current. We have solved one problem based on that. Okay. Now in lecture 25th, we have seen interruption of capacitive current. We have capacitive current. Okay. Now in lecture 26th, we have different types of circuit breaker. We have air circuit breaker, air blast circuit breaker, oil circuit breaker, SF6 circuit breaker, and vacuum circuit breaker. Okay. Now in this lecture, we have seen air circuit breaker. Now while uploading on YouTube, what happened? I have uploaded two videos for lecture 26, because you know, in first video there is a certain noise, so I have uploaded it again. If anyone wants to watch, they can watch it again. Okay. Working principle of air circuit breaker and working principle of air brake circuit breaker we have seen in this lecture. Okay. Lecture 27, oil circuit breaker we have seen. Okay. In lecture 28, Sulfur hexafluoride circuit breaker we have seen. How sulfur hexafluoride circuit breaker works. We have seen advantages and disadvantages. In lecture 29, we have seen vacuum circuit breaker. Okay. Now in lecture 30, we have seen circuit breaker ratings and their testing. Okay. Now, just for revision, I will just tell air circuit breaker we are using for small voltage application, that is below 1 kV, while vacuum circuit breaker is applicable for medium voltage ranges 3.3 kV to 33 kV. Although we can use SF6 circuit breaker, minimum oil circuit breaker, but vacuum circuit breaker is preferred. For 132 kV to 220 kV, SF6, air blast, minimum oil circuit breakers are used, but we are preferring SF6 circuit breaker because they are most economical. For 400 kilovolt to 7 kilovolt for high voltage application, extra high voltage application, although SF6 and air blast we can use, but SF6 is preferred because it is more economical. Because air blast circuit breaker have drawbacks because it requires more maintenance, while vacuum circuit breaker for high voltage application also require maintenance. Okay, so for that we are using SF6 circuit breaker for high voltage application, where it is more economical than vacuum circuit breaker for high voltage application. Okay, now here we have covered all your 30th lecture, discussion on 30th lecture. Okay, now any doubt you can write in chat box. Write in chat box. Any doubt? What we are doing? Any doubt in circuit breakers? Any doubt in circuit breaker? No. Somnath, Himanshu, Sanket. Okay. Okay. Aditya. Okay. Abid. Okay. Abid, you joined late. Gauri, also you have joined late. Okay. Now again, give me 5 minutes. What I am telling? You can unmute yourself and you can tell tomorrow is the last lecture, or you can we'll have last lecture as 36th lecture. It will be on. You have to share. You have to share one topic from your side. Okay, you have to share the topic you like, or the topic you understood most, and your doubt you have to share. So for that we require 1 hour, 1 to 1.5 hour lecture. No, about CT we don't have any update. Definitely it will be postponed till further order. It will be postponed till further order. So the CT will not be there in this or in next week also. Okay. Now tell me, tomorrow or day after tomorrow, you tell me the time convenient to you. When can we take a complete discussion lecture? Because in that you have to share the topic. Tell me. CR, Gauri, Abid, tell me, or you can unmute yourself. Any topic from the syllabus, any topic you can take. Any short topic or big topic, whatever you want to take, you can take. Related to switch gear and protection. You have to write in the book. You have to write in book and you have to share. ऐसा भी कर सकते हो आप कि पहले लिख कर रख सकते हो, बाद में जब मैं आपका आईडी कॉल करूंगी तब आपको वो शेयर करना है. आईडी वाइज मैं आपको कॉल करूंगी ऑन दिस लाइव लेक्चर. समझ में आया? लास्ट लेक्चर कैसे रहेगा हमारा? लास्ट 31 लेक्चर विल बी कैसे रहेगा? आईडी वाइज आई विल कॉल ID1 and the ID1 will share their topic, his or her topic on live WebEx. Okay, I will just see that. Okay, and he or she will share his doubt also. वो डाउट शेयर करने के बाद में आप पहले से लिख कर रख सकते हो. सेकंड आईडी भी शेयर करेगा. थर्ड आई विल कॉल आईडी वाइज. समझ में आया सबको? तुषार, गौरी, अबीद, हिमांशु, ठीक है. अच्छा, कब रखना है ये मुझे बताओ. कब रखना है मुझे बताओ. कब रखना है ये ऐसा लेक्चर मुझे बताओ. मैं फिर से रिपीट करती हूँ. हमने क्या करना है, लास्ट लेक्चर कैसे रहेगा हमारा, तुमको पहले से ही तुमको जो टॉपिक अच्छे से समझा है वो लिख के रखना है, और जो डाउट तुमको है वो लिख के रखना है, वो तुमको शेयर करना है फ्राइडे. हाँ, आई विल एक्सप्लेन द प्रोसेस. मैं वो आपको प्रोसेस पहले एक्सप्लेन करूंगी, फिर आपको शेयर करना है. हाउ टू शेयर. चौर्य, आई विल. कोई भी ले सकते हैं टॉपिक, कोई भी ले सकते हैं. स्विच गियर प्रोटेक्शन का कोई भी टॉपिक लो, चाहे फ्रेम लीकेज प्रोटेक्शन लो, चाहे जनरेटर का एक लॉस ऑफ एक्साइटेशन लो, चाहे सर्किट ब्रेकर लो, कुछ भी लो, और जो तुमको डाउट है वो भी. ठीक है, समझ में आया? वो तुमको आईडी वाइज शेयर करना है. पहले से लिख के रखो तुम, नो डाउट. तुम पहले आज लिख के रखो, कल लिख के रखो, और फिर वो सिर्फ शेयर करना है. समझ में आया? अच्छा, कब लेना है? फ्राइडे. प्रिया टोल्ड टेक ऑन फ्राइडे. आपके साइड से और कौन कौन? इस फ्राइडे इज ओके. हिमांशु, फ्राइडे. When to take? Friday. Okay. Okay. Abid, okay. So Friday at what time? Friday at what time? Friday at what time? Okay. 10:30. ठीक है. ठीक है. Okay. Okay. 10:30 to 11:30. It may be up to 11:45 also. ऐसा हो सकता है, क्योंकि 11:30 तक अगर खत्म नहीं होगा 11:45 तो 12 तक भी जाएगा, है ना? तो ऑन फ्राइडे वी विल हैव लास्ट लेक्चर ऑफ SGP. ठीक है, ओके.